All right. All right, this is the Module 2, Chapter 2 sets and whole numbers, number theory, and Chapter 3 numerations and computations? I don't know. For Miss Benzi's class. And I'm Danielle Gillham.
Hi, Danielle.
Hey. And then we
I'm
got
Josh Mills.
And then Sydney.
Hi, Sydney.
Yes, I'm Sydney. Hi.
And let's get started. All right. So a union is a new set formed by two sets that contain all of the elements that are in at least one of the two sets. So it can be them combined, or it can be either or. So when you have your regular U shape, it's going to be a form of a new set that contains an element that have A and B. And so it's going to be considered as or. So when you have your upside down U, it contains the elements that are in both A and B together. All right, so let U equal all of these numbers A through H. These are the numbers A equals, B equals, C equals. So we're going to use a Venn diagram to show all of the elements of U, then list the elements in the set. So here's a Venn diagram. All right, so A is in A and B, but not C. So it's going to go in the middle of A and B. And then B is only in A. C is unfortunately not in A, B, or capital C, so it's going to be out in the field of U. Lowercase d is only in A. The lowercase e is in C, but not A or B. F is in capital A and capital C, so it's going to go in between the A and the C. G is only in B. So the lowercase h was in all of the sets, capital A's, B, and C. Therefore, it is placed right in the middle. All right, so let's do the sets. So you have B and C. So B and C together are A, B, D, F, G, and H. And that's there. And then there's A or B. So A and B, they together have A and H in common. So that's your answer for that one.
Awesome, awesome.
B or C, the only one B and C has in common is H. A and C together is A, B, D, E, F, and H. All right, and A is C, G, and E because in these parentheses, brackets, C, G, and E is not contained in it. So A means no or not involved. A and C over here is going to be A and C have in common is F and H. So this one's a little different. It's called a distributive law. As you can see, this is the problem. So this also means
Like
this.
distributive properties.
Mm-hmm.
Awesome sauce.
So it can be seen as both ways on those. So basically, you're going to do the parentheses first, which B and C only have in common is H. And then you're going to add whatever is in the bracket of A along with the H. So this one was a little easier because it already had H. But if there was no H in bracket A, then you would just be adding H. So it's A, B, D, F, and H. Hey, Sydney, how can we classify the shapes in the diagram based on the notation provided?
Okay, so the way that I would start is to just dissect what we have in front of us. And what we have are three different shapes. So we have triangles, hexagons, and circles. And they come in large sizes and small. And they come in red or blue. And then we can represent those with the letters of each like characteristic, I guess. So within that diagram, we have T, H, C, R, B, L, and S, and that represents everything that's represented in there.
Right.
So
Making sense.
we can use exactly what Danielle is talking about with unions and intersections. And so for CUH or C union H, that would mean that we would either have circles or hexagons, but then for L intersection H, we would have hexagons, red hexagons or blue hexagons.
Okay. It's pretty neat that you can use shapes instead of letters.
And colors. All right. So we're going to go, and it looks like we're on problem 3. We're going to be doing historic math. And so how we look at this is in Egyptian era, we had fingers like so that represented numbers back in the day, and different shapes and patterns like we would call hieroglyphics. All right. And so how we look at this is, notice that the fingers represent 10,000. And so the fingers represent 10,000. The N symbol, or looks like a upside down U, however you want to put it, represents 10. And then the 1 symbol, the single slash, represents 1. Pretty simple stuff. And they would put them together, and how this would look like, and you go ahead and click that forward.
Okay.
So there you go. So because each one finger represented 10,000, the fingers, we have 4 fingers, so we would multiply those together. We would multiply 4 times 10,000, and we would get 40,000.
Okay.
On the next one, we would get represented, the N represented 10. Again, we have 4 N's, and it represented, it equals to 40. And then I'll go next with the slash. The single slash was 4 single slashes, which also represented 4. And you put them together, and what do we get? On the next slide. So all that together, we get 40,044. Cleopatra is making money. So let's go on to the next one. Crazy. You girls like money, don't y'all? Just kidding. All right, so now we're on to the Romans and how they did math. It's pretty neat how the Romans did math. So the Romans would.
Sorry.
It's all good. The Romans would go into different sets, and they would write letters instead of numbers. And how they would do this is that they would do combined numbers. So where the letter I would be equal to 1, D would equal 5, X equals 10, L equals 50, and C equals 100, D equals 50, and M equals 1,000. Now there's a little mix up because in some of these you can't have combined terms on that, but once you have the set, excuse me, of the Roman numerals, you would add those together. So we knew that M equaled 1,000, D equals 50, and X equals 10, and then V equaled 5, and then I 1. So now as we go on, go to the next slide, please.
So are you just adding these together, Josh?
Correct. So as we go down, you go ahead and click through it. The total was 1,526. And so this is how this would work, is the X, as we have it, you combined 1,000, all right, where D was 50 and X was 10, but like you would do 10 plus 10, so that would actually equal to 20, all right.
Okay.
I think I messed up somewhere. I apologize. Let me do that again. I might have meant to put for X. What was X? Was X? I think I messed that up. I did do that. Can you go back to the other slide?
Yeah.
Yeah, okay, I did that right. So that's what I did. I messed up on. So that would be, I think I messed up on the total. So I forgot to rechange the total because I had done another problem.
So how do you add up the totals then?
So what basically go back down again and scroll all through. So M was equal to 1,000.
Mm-hmm.
Had D, all right, and with the D you had 50, all right. X you have with the X Roman numeral, the thing. Where's my notes? On the Roman numeral for X, there was 2 X's there, so one of those is going to be combined, kind of like terms in a sense. But let me get to it. Guys.
So if you're just adding up all the the Roman numerals or whatever, is it just
Right.
1,000 plus 50
So if this
plus
was
2 tens?
right, so if there was 2 X's, you would subtract. Where was it? So that's where. That's where I messed up. No. So D is 500. Is that correct? Go back. I meant to put 500 on there. That's where I messed up on. I apologize. D is 500.
Oh, okay.
So I apologize. I was like, man, I don't know how I messed up on that, but I apologize again. All right. So basically, that's what you do. You're gonna put. You're gonna get the numerals. Awesome. Thank you, Danielle.
Mm-hmm.
Like, wait a minute. I know I did this right at first, but I guess so. D equals 500. And so when you get there, you have 2 X's, 2 X's combined. All right. And you have 10. All right. So 2 X's, and then you had 5 with the Roman numeral 5 and a 1. So X plus X is 20. So that would be 20. And then so it would be 1526. And that was your total. And that's how you got the total through Roman numerals.
Okay, that makes sense.
I made that harder than what it was. Sorry, guys.
No, it seems pretty easy now that you explained it.
It was easier than it's supposed to be. That's what I meant to do. So there we go. So 10 plus 10 was 20, and then vice versa. All right, now we're on to Babylonian math, and it's kind of weird. They had plants and marks, little slashes in their marks. I don't know, man.
It looks kind of confusing.
Yeah. So hopefully this diagram explains this, but like, let's continue on to the next slide. So those little slashes equal 1. All right. So each slash equals 1, and the flower looking slash it equals to 10. And so as you see down at the bottom, you would multiply these together, and so we had 5 slashes, which is and that's supposed to be reversed the other way around. You had 5 slashes plus the flower, which equaled 51 times 1, and it came out to 51. So, and that's how it works out. All right, and then on the Mayans, so we'll turn around for the Mayans as we go down. They got a little bit, so they'll have dots, and they go to dots. So every 4 dots, you get a slash, and so every dot that comes in, every 4 slashes, you get a dot on some of these. Now let's go ahead and go to the next slide. All right, as we got this, we have a place value, and you want to stack the Mayan numbers together, and they're going to go just like this. So if you're going to add these Mayan numbers together, so the slash, as we from previous one, go ahead and click on it again. All right, well, the 1 slash equals 5, and click again. 6, and so forth. Keep clicking until you get all the numbers. This was going to be 18, I believe. Coming up should be. And those are the place values of each. So now let's look at this before you hit anything else. So the bottom one is going to be 18. So this over here is going to be 18. And the bottom one is at the very bottom. So that is going to be multiplied. All right. So you'll multiply the bottom one with the 1. All right. The top one you're going to multiply with the 7,200 place value is going to be multiplied by 7,200. So that would be 5 times 7,200, and then you get a total. The next one, the second one is going to be 6. All right. So that symbol, it means 6, and you would multiply that 6 times 360 because that is the second place value. Then the third place value, you would multiply 3, which that symbol means 3, to 30, which is the third place value, and so forth. And then once you get a grand total of the whole thing, you will multiply them and then add them together, and that is your total. Let's go ahead and click. Notice that we pointed the arrows to those. And that meant 18, so I don't know how 18 didn't show up on there. I had it on there. All right. And there it is.
There it is.
So I apologize. So, but there it is. You have 38,268. So notice how you added those together. First, you multiplied the place values. So you would multiply across, and then you would add the place values total once you've had that multiplication together. And then you have it.
Okay. So this algorithm is multiplying, and it really made things really simple. I liked it a lot. So we're going to multiply 63 by 92 using the, I think you say Lattice or algorithm.
Lattice?
So,
I don't know. Lattice? Is that French?
I think so. I'm not sure. So you're going to start out with, you can start however you want, but I just started right here. So 3 times 2 is 6. So there was no tens place digit, so I put a 0. And then 3 times 9 is 27. And then 6 times 2 is 12. And 6 times 9 is 54.
I like it. I like it.
Okay, so then you're going to start adding this way diagonally to find your numbers. So your sets is, of course, going to equal sets. And then 2 plus 0 plus 7 equals 9. And then 1 plus 4 plus 2 equals 7. And then 5 equals 5. So there's your sets. Your 9, 7,
so we're adding the
and 5. So your answer is going to be 5,790 sets to the answer of 63 times 92.
Whoop, whoop.
And here's another one. We're going to do a 3-digit number times a 2-digit number. So 7 times 2 is 14. And then you also have 7 times 2 right here. And there. And then 7 times 7 is 49. Here's another 7 times 7, 49. And 2 times 2 is 4. And of course, there's no number in the second spot, the 10th spot, so there's going to be a 0. And this one's going to be a little different because we're going to have
A carryover?
yes.
Awesome. I like it.
So right here, you're going to have 9 equals 9. And then your 9 plus 4 plus 4 equals 17. So that's where we got this. The 7, and then the carryover 1 over here. And then 4 plus 4 plus 4 plus 1 equals 14. Here's your 4. Carryover 1 will go up to your next diagonal. 1 plus 4 plus 1 equals 7. Or 6 plus the 1 equals 7. And then 0, 0. So you're going to scratch out the 0. And 277 times 27 is going to equal 7,479.
Smooth operator.
It's pretty easy. All right, Cindy, why is rounding important and how does it help with mental math?
So rounding really helps you do the math in your head, and it can help with things like money. A lot of the time I would use the example of money for like anything math related. And so with the number hill up on the right hand corner, you can like help keep the idea in your mind that if it's below 5, it rounds back down to 0, or if it's equal to 5 or over 5, you round up to 10, or like up to the next position. And so with our problem, 26 plus 41 plus 87 divided by 38, we need to start rounding the numbers. So 26 would round to 30, and 40 would round down to 40, and then 87 would round up to 90, and 38 would go ahead and round up as well to 40. Okay, and then once we have those numbers, we can just go ahead and plug those back in and actually do the equation. And so we do 30 plus 40 plus 90 is 160 divided by 40. And, you know, that's just basic math. And that just comes down to 4. And really, you can just knock off those zeros and just do 16 divided by 4 if you want. And so then you end up with...
I like it.
Oh. All right. I guess I could control some of this, right? No?
Mm-mm.
I can't. What is it? Oh. All right, so give me 1 second. Just
Do I need to click anything?
no. All right, so anyway. Okay, so anyway, all right, so now we're working with the powers of 5. All right, so powers of 5. So how we work this out is you're gonna have 532 to the power of 5, all right, plus 113 to the power of 5. Go ahead and click. So, and how this works is we're gonna go by 5s. We're gonna work this in sections of 5s, all right? So we know that in the 1, 10s, and 100 spots. So we're gonna do, so this would be 5 to the 5 to the first power, 5 to the second power, correct, yeah, 5, and then 25, all right? And so how you would do this is you would take 532 and you would go 5 times 25 would equal to 125. All right. And then on the next one, you would do 3 times 5 would be 15. And then you would do 2 times 5 would equal 5. And so you would add 125.
2 times 5 or 2 times 1?
2 times 1. I apologize.
Okay.
On me. You would add 125 plus 15 plus 1, and you would get 141. All right. And then you would do the vice versa to the other place. So it would be 25 times 1, 5 times 5, and plus 3, because 3 times 1 is 3, and you would get 29. All right. And then you add those together, and then you would get a grand total of, go ahead and click it. It'd be, I think it's 170. Yep. So then you get a grand total of 170. All right. So now we're going to do like a power of 6. And so let's do a power of 6. So as we're going on to power of 6, go ahead and click it. We're going to do the same thing. So the difference is you would be 6 times 36 would be would be 216, and then you would do 4 times 6, which would be 24, and then you do 7, and so you get a grand total of 247, and then you would add those together. Then on the next one, you do 8, so 8 again, vice versa. 8 times 36 would be 288, and then you would do 2 times 6 would be 12, and then 4 times itself, and then you would get a grand total of 304, and you add those together, and you should get 7. Or let's see, hold on. Yeah, is that right? Yeah. All right, so you add those together, and you get 551, and that's how you would get the power of 5. Did that make sense to y'all? I don't want to confuse y'all.
Yeah.
So as you get the power of 6, you got to multiply. So at that section of that power. All right, let's go on to the next one. All right, so now we're going to subtract the power of 5. All right, and so I kind of made this little diagram here. So go ahead and click again. Hey, click one more time. I'm missing the power of 5 up top. So anyway, no worries. Improvise right here. So the power of 5. So this would be 5 to the 0 power, 5 to the 1, 5 to the 2, 5 to the 3. All right. And so how that works out is you're going to get, I don't even know how that even ended up that way. Anyway, it would be 321 minus 243. All right. And so how that works out is 321, you would subtract, you keep the 5th power instead of borrowing a number. Apologize. I'm gonna do this right here. I think this is like, I think when we converted it to like Google Slides, it messed it up. So you had 321 and you have 243. And so what you're gonna do is in this section, you're gonna have, you're gonna borrow from the 2. So you would line them up like normal subtraction. And if you could draw that out for me at the bottom, that'd be great. I don't know how to.
Just cross out the 243 on the top, or
No, go ahead and just write it out. Yeah, real quick. 321. I thought there was a way for me to have control too, but I didn't know.
and then do a 5 at the bottom.
Yeah, so you would do 2 minus 243. Yeah, do the power of 5 at the bottom minus 243. So it's like normal subtraction with the power of 5 at the bottom of that. So it's like normal subtraction. And so as we do this, we would do 3 minus 1. Well, obviously we can't subtract 3 minus 1. So what we would do is we go 3, we have to borrow. So we go, hey, number 2, what's up? He's like, hey, what's up, man? Like, I got to borrow this. Well, you're not going to do the normal borrowing, all right? So you automatically make that a power of 5. And so like by borrowing it, you make that a 5. All right. So it's going to be, instead of a 5, it's going to be a 4 on the top of the 2. So as you do that, you make the other one, you would think that number 1's going to be 11, but that's not the case. It's going to be, instead of 11, it's going to be 5. So the 1 will become a 5. And you go 5 minus 3 is, actually, it would be a 6. Apologize. Because you would do 5 plus 1 is 6. And then you make that in. And so 6 minus 3 would equal to 3. And as we move on, so 4, all right, so now 4, I think this is all messed up. Did I do that right? I think I did that right. I don't think I did that right.
Oops, sorry.
Give me 1 second. Sorry, guys. Correct. All right. So you would then make that. You would make that 4. You would take the 2 down. You would take the 2 down because you got to borrow from that. I didn't do that right. Because it would be 243, and you make that. All right, let me get this. Guys, can we redo this video? I know you're gonna kill me because, like, for some reason, I think when we converted it to Google Slides, it like mixed up all my stuff. Is that what we did?
Hold on. Let me start recording for a sec. Well, the only thing is Sydney, she has to be at work at 4.
I'm sorry, Sydney.
It's okay.
Let me
Resume. Okay.
all right, so back to this. Now we got our powers of 5 and how this worked out on this certain section. We're gonna come over here. You have the power of 5 to the 0, 5 to the first, 5 to the second, and 5 to the third. And when you get this, you would subtract. And so how this works out is you come over, and this would be a 3. Let me get this. So we know these are 3s. So this would be 3. Hold on, let me write
Just click pen.
that. All right, so this would be 3. So I'm just going to write over this. Well, there we go. So that would be a 3, and this would be obviously a 2. Not a great 2. Sorry. And then a 1. All right, so we'll just pretend that as a 1. So anyway, as this comes through, we subtract it, and as we're going, so we know that automatically, and this would be a 1. This would be canceling out here pretty soon, but so you have to have 3 borrowing from the 2. And as we borrow from the 2, we got to come over, mark that off. So we scratch it out. Normally we'd make that a 1, but we make it a 5 instead. So as we make this a 5, then we turn around, and then this would come in, and you would make this, you're borrowing that 1 from 5, so we know that that is now going to be, this one's going to be a 4, and this is going to be a, this one's going to be a 6, because you're adding 6 plus 1, and then you're going to minus 3. And so we have down here 3 to the power of 5. And then this one, you would turn around and you would go, this one would subtract out. And I don't think I did this right. Sorry, guys, I screwed this up. I don't think I did that right. So, I did that. Yeah, I did this. My fault. That's on me. What is
Do you know how to do this, Sydney?
No. Because the way that I did it on my presentation, I didn't use the chart like that.
so it would be 321 minus 243. You subtract, borrow the 2. Here, I'll just do it right here. So you would borrow this, and you would not make that a 6, would you?
Here we go.
All right, so that would be, back to what I was saying, we had 321 minus 243, and it's a power of 5, so we borrowed borrowed 1 from 2. So we come over and we make this a 5 plus 1, that would equal 6, and then you would subtract 6 minus 3, and you would get 3 to the power of 5. Then we're going on to the next one. So 4 minus 1, you can't do that, so we have to borrow. So we knock out the 3, and the 3 would be 2, and then you come over and you make that. But there's a catch to that. You would make that a 6 because you're adding the 1. And so that would be 6 minus 4 would be 2. And you got 23 to the power of 5 because 2 minus 2 is 0. And that's how you get that. So forth.
Okay.
Made that hard again.
That's it.
Yep.
All right. Well, that concludes our presentation. And thank you for learning with us. And